Hey there, green thumbs. Ever feel like your pepper seedlings are playing a game of who grows fastest?
Even when you're giving them the same TLC.
Yeah. We've got a deep dive for you today.
All about those tiny habaneros.
And the surprising power of genetics?
Definitely.
You've been sharing with us that your habanero seedlings are growing a bit unevenly.
Yeah,
And you're trying to figure out why.
for sure.
It's like they all got the same invite to the growth party, but some RSVP'd yes with way more enthusiasm than others.
Interesting.
Well, get this. We found this blog post by Ang,
Okay.
who calls himself an old software plumber turned pepper enthusiast.
Oh, wow.
He's over on kianmeng.org,
Go
chronicling his gardening adventures.
Love it.
And in his latest post, Notes on Gardening, part 438.
Wow, 438. That's a lot.
Yeah, he's been doing this for a while.
Clearly.
He's wrestling with the exact same mystery you are.
Oh, really?
Some of his habanero seedlings are just ahead of the game.
Huh. Interesting.
Same parent plant, same soil,
Got it.
same everything.
So what gives?
At least that's what he thinks.
Yeah.
So what's the deal?
Right.
He's starting to suspect it's all about those genes.
He's on the right track.
Really?
Yeah.
So it's not just about whether a seed is viable or not.
It's more than that.
There are levels to this.
Absolutely.
Wow.
There's this incredible genetic diversity,
Okay.
even within the same pepper.
Hmm.
Think of it like this.
Yeah.
You and your siblings might inherit your parents' eye color,
Mm-hmm.
but maybe one of you has a slightly different shade
Okay.
or pattern.
Aye.
It's the same with these habanero seedlings.
So some might be predisposed to be taller,
Exactly.
bushier,
Uh-huh.
or maybe even spicier, right?
You got it.
Wow.
And these genetic differences can show up in some pretty fascinating ways,
Like what?
especially when it comes to things like germination speed
Okay.
and early growth.
Interesting.
There's actually a specific gene, it's called CGR1.
CGR1.
Yeah, that plays a big role in how fast habanero peppers germinate.
Wait, there's a gene specifically for that?
Yep.
Wow.
And variations in this gene
Mhm.
can explain why some of your seedlings might be popping up
Okay.
and putting on growth faster than others,
Interesting.
even under the same conditions.
Really?
It's like some have a genetic fast pass
Mm-hmm.
for early development.
I never realized there was so much happening
It's wild.
at the DNA level.
It is.
This is making me look at my pepper seedlings in a whole new light.
It's amazing, isn't it?
Yeah.
And what's even cooler
Yeah.
is that Ang's noticed something else
What's that?
that could be at play here.
Okay.
He mentioned that he scattered his seeds
Mm-hmm.
when he first planted them
Yeah.
instead of placing them individually.
So kind of random.
Right.
Interesting.
He's wondering if that randomness
Fine.
might have actually given some of the seedlings a head start.
So even if it's not all about the
The genes.
CGR1 gene, maybe some seedlings just got luckier with their landing spot.
Exactly.
Like a lottery.
It's like some of them ended up in the first class section of the seed tray.
Uh-huh. I like
They might have had better access to moisture,
Okay.
nutrients,
Mm-hmm.
or even just a bit more space to stretch their roots early on.
Interesting.
And even those tiny advantages in the beginning
Okay.
can make a difference in how they grow later.
So it's like those kids who get a head start in preschool.
Exactly.
They might not all be geniuses,
Right.
but that early advantage gives them a boost, right?
That's a great analogy.
Thanks.
And it highlights why those early stages of a seedling's life
Mm-hmm.
are so critical.
Yeah.
Even subtle differences in their environment,
Oh.
like depth of planting or how much light they get,
Yeah.
can have a lasting impact on their development,
Wow.
just like in those early years for humans.
So we've got these genetic variations in play.
Right.
Some seedlings might just be programmed to be faster growers. And then we've got these environmental factors that can give some a leg up, even if it's just by chance. It's like
Yeah.
a nature versus nurture battle happening in my seed tray.
That's a great way to think about it.
And Ang's really tapping into that with his next move,
Oh, yeah.
which is so smart.
Tell me more.
He's going to start another batch of seeds,
All right.
but this time
Yeah.
he's going to be super precise about how he plants them
Nice.
and what kind of soil mix he uses.
He's taking control.
Yeah, he is.
By controlling those variables,
Right.
he'll be able to see more clearly whether it's the genes or those early environmental differences that are having a bigger impact on his seedling's growth.
So cool.
It's like a botanical detective story.
I love it.
I have to know more about this experiment.
We do.
But before we go there,
Yeah.
can we talk about those hormones you mentioned earlier?
Oh, yeah. The ones that control growth.
Right.
I'm picturing them like tiny construction workers building those stems and leaves.
Yeah. They're not that far off.
Haha, really?
So plants have these amazing chemical messengers called hormones, and they play a huge role in how a plant grows and develops.
So cool.
Remember those CGR1 genes we talked about?
Yeah.
Well, they actually influence how much of a hormone called gibberellin a seedling produces.
Gibberellin, got it. And
Yeah.
what does this gibberellin do exactly?
Think of it as a plant's growth spurt fuel.
Okay.
It basically tells cells to elongate and divide,
Interesting.
which leads to those stems stretching and leaves unfurling.
So cool.
So those seedlings, with a variation of the CGR1 gene, that leads to more gibberellin production.
Yeah.
They're going to be the ones shooting up faster.
So it's not just that they germinate faster. They've got a built-in turbocharger for growth, thanks to their genes.
Pretty cool, right?
This is getting seriously cool.
There's more.
Wait, you mentioned other hormones, right?
They did.
There's more to this story.
There's a whole symphony of hormones happening in a plant.
Wow.
But another key player is auxin.
Auxin.
Yeah, it's like the architect of the plant world.
Oh, wow.
Directing root development.
Okay.
And making sure those roots are growing in the right direction.
So gibberellin's for the above-ground action.
Yes.
And auxin's down below, building the foundation.
Exactly.
That makes sense.
Good.
But how do these hormones play into the whole genetics puzzle?
Well, just like with gibberellin production, different genes can influence how sensitive a plant is to auxin.
Okay.
Or how much of it produces.
Interesting.
So even if two seedlings land in the same spot with the same amount of nutrients and moisture, their genes could be making them respond differently to those signals from auxin.
So one seedling might be saying, auxin, let's build some serious roots. While another one's like, nah, auxin, I'm good for now. I'm going to focus on growing tall.
Yeah, that's a good way to put it.
This is amazing.
I know, right?
It's like they each have their own internal blueprint based on their genes.
Exactly.
And they're responding to those same environmental cues in slightly different ways.
That's the beauty of it.
This is making me realize that there's a whole invisible world happening beneath the soil surface.
For sure.
And it's all being orchestrated by these tiny genes and hormones.
It is.
I can't wait to hear more about Eng's experiment and what he's discovered.
Let's do it.
This is like plant science meets reality TV.
I love it.
And I'm totally hooked.
Well, let's dive into those details.
Yes, please.
Eng's findings are pretty revealing.
Okay.
And they might just change the way you think about starting those precious pepper seeds.
I can't wait.
Welcome back, pepper enthusiasts.
We left off talking about Eng's super detailed experiment with his habanero seedlings.
Right.
Where he's trying to crack the code on why some are sprinting ahead while others are taking their sweet time.
Exactly.
It's like a plant version of those time-lapse videos.
I like that.
Except we're trying to figure out why some are on fast forward.
Good analogy.
And remember, he's working with the same batch of seeds.
Yeah.
So the genetic variation is relatively controlled.
Makes sense.
Right. So it's all about isolating those environmental factors that might be giving some seedlings an edge.
Exactly.
So spill the beans. What did Eng find out?
Well, his results were really interesting.
Okay.
For his second batch of seeds, he ditched the scattering method.
Okay.
And very carefully planted each seed at the same depth.
So really taking the time.
He was.
Giving them equal spacing.
Exactly.
Okay. So he created a super consistent environment, like a habanero boot camp with everyone following the same drill sergeant.
I love it.
Well, what happened?
Well, it turns out that consistency was key.
Really?
The seedlings in this second batch grew much more uniformly.
Wow, so they all did pretty much the same.
There were still some slight variations in height.
That makes sense.
But overall, they were much closer in size and vigor, compared to the seedlings from his first batch.
Right, the ones where he just scattered the seeds.
Exactly.
So even though those seedlings still had those inherent genetic differences, some might be naturally faster growers because of those CGR1 variations.
Exactly.
That more controlled environment really leveled the playing field. It's like everyone got the same training and nutrition. So those genetic superstars couldn't just rely on their natural talent.
That's a great way to put it.
Thanks.
And this is where it gets even more intriguing.
Oh.
Eng noticed that the seedlings in the second batch, the ones with the controlled environment, actually developed stronger root systems overall.
Whoa, so it wasn't just about above ground growth?
It was more than that.
It was like they were building a better foundation below the surface, too.
Exactly.
Fascinating.
And that makes total sense when you think about the role of those hormones we talked about earlier.
Yeah.
Remember auxin, the root development architect?
Yeah.
Well, by making sure the soil had good drainage and aeration.
Okay.
Aang essentially created an environment where those roots could really thrive.
Interesting.
And respond to auxin signals more effectively.
So even though those seedlings might still have had different levels of auxin sensitivity based on their genes,
Yes.
that optimized environment allowed them to make the most of whatever auxin they were producing.
Exactly.
It's like giving all the athletes the same training facility.
It is.
Even if some have a natural advantage in strength or speed.
That's a good analogy.
And this is a great takeaway for any pepper grower.
Totally.
Even if you're not doing a full-blown experiment like Aang.
Yeah, I agree.
Those early decisions you make about your planting technique and your soil mix can have a huge impact on how your seedlings develop.
They really can.
Both above and below ground.
Absolutely.
So it's not just about finding the best seeds.
It's more than that.
It's about giving those seeds the best possible environment to express their potential, right?
Absolutely.
And that's what's so cool about gardening.
Tell me about it.
It's this fascinating dance between nature and nurture.
I like that.
You can't control everything.
True.
But you can definitely stack the deck in your seedlings' favor.
You can.
By creating those optimal conditions for them to flourish.
Exactly.
This is giving me a whole new level of respect for those tiny seedlings.
Me too.
They're not just passive little sprouts.
They're not.
They're responding to their environment.
They are.
They're communicating through hormones.
They're creative.
They've got this whole complex world happening below the surface.
I know, right?
It's incredible.
It is pretty wild.
And it makes you realize that there's so much we still don't know.
Absolutely.
About how plants grow and develop.
I agree.
But that's what makes it so exciting to keep learning and experimenting.
It really is.
Speaking of experimenting, I can't help but wonder about those breeders who are creating all those amazing pepper varieties we see today.
It's pretty amazing.
Are they basically doing what Aang's doing, but on a much larger scale?
Yeah.
Selecting for specific traits?
Uh-huh.
And manipulating those genes to create super peppers?
They are.
No way.
It's true.
That's so cool.
It's like they're composing a symphony of genes.
Okay.
Carefully selecting and combining traits.
Yeah.
To create those flavor profiles, heat levels, and growth habits.
Interesting.
That make each pepper variety unique.
So they're not just working with those naturally occurring variations like those CGR1 genes.
Exactly.
They're actually manipulating the genetic code itself.
They are.
That's wild.
It is pretty incredible.
So there are people out there who are like pepper geneticists.
Yeah, basically.
That's so cool.
It's pretty amazing.
And there are a few different ways they do this.
There are.
Okay, tell me more.
One technique is called selective breeding.
Okay.
Which is basically what humans have been doing with plants and animals for centuries.
So like the old school method?
It is. It's all about choosing parent plants that have the desired traits.
Okay.
Like a certain color.
Yeah.
Size or flavor.
Interesting.
And then crossing them to produce offspring.
Okay.
That hopefully inherit those characteristics.
So if you want a super hot habanero,
yeah.
you'd cross two of the spiciest peppers you can find and see what happens.
Exactly.
And hope for the best.
And then over multiple generations,
yeah,
breeders carefully select the offspring that best express those desired traits.
Okay.
Gradually amplifying those characteristics over time.
Wow, so it takes a long time.
It can.
It's like a slow and steady process of genetic refinement.
It is.
Cool.
It's like those dog breeders who are trying to create the perfect poodle.
I like that analogy.
Except with peppers, it's all about the heat.
Yeah.
The flavor. And maybe even the shape and color, too.
So many possibilities.
Right.
And then there's hybridization.
Yes.
Which takes things a step further.
It does.
Okay, tell me more.
It's all about crossing different varieties.
Okay.
Or even species of peppers.
Wow.
To create hybrids that combine desirable traits from both parents.
So you could potentially cross a habanero with, say, a bell pepper.
Yeah.
To create a mild habanero with a sweeter flavor.
Theoretically, yes.
Really?
Although it's not always that simple.
I see.
Hybridization can lead to some really interesting combinations.
Okay.
But it can also be a bit unpredictable.
It's like those cooking shows where they give you a mystery basket of ingredients.
I love it.
And you have to create a dish.
Right.
You have to be creative and adaptable.
That's a perfect comparison.
Thanks.
And that's where the real artistry of breeding comes in.
Interesting.
Breeders have to use their knowledge of genetics.
Okay.
Their keen observation skills.
Yeah.
And a bit of intuition.
So it's a skill
it is.
To guide the hybridization process and select the most promising offspring.
Exactly.
So it's a blend of science and art.
Yes.
Kind of like a mad scientist meets a master chef.
That's a great way to put it.
But wait, you mentioned something about manipulating genes directly.
I did.
That sounds like next level stuff.
It is.
Okay, what is that all about?
And that's where genetic engineering comes in.
Okay.
This is a more recent and advanced technique.
Interesting.
That allows breeders to actually modify the DNA of a plant.
Whoa, so they're going in there and changing things.
They
at
are.
the tiniest level.
That's pretty wild.
That's crazy.
Introducing specific genes from other organisms.
Okay.
Or even synthesizing artificial genes.
Really?
To create peppers with desired traits.
Whoa, now we're talking sci-fi.
It is pretty cutting edge.
So could you potentially engineer a habanero that glows in the dark or something?
Well, maybe not glow in the dark yet.
Okay,
But the possibilities are pretty incredible.
So cool.
For example, you could potentially engineer a habanero that produces more capsaicin.
More capsaicin?
Yeah.
And remind me what that is again?
The compound that gives peppers their heat.
Oh, yeah. So like a super duper spicy habanero. Exactly.
That would make even the most seasoned chili head sweat.
You got it.
Wow.
Or you could engineer a habanero that's resistant to a specific disease.
Okay.
Or pest.
That would be great.
Making it easier to grow.
Yeah.
In certain climates or conditions.
So it's like having a genetic toolkit where you can tweak and fine-tune the pepper's blueprint.
Exactly.
To create exactly what you want.
Pretty powerful stuff.
That's amazing.
It is.
And kind of scary at the same time.
It's definitely a powerful technology.
Yeah.
And there are important considerations about its safety and ethical implications.
I can see that.
But for now, let's focus on the potential of these breeding techniques.
Okay.
To revolutionize the way we grow peppers.
So for our listener who's now dreaming of becoming the next pepper breeding superstar.
That's awesome.
What's the key takeaway here?
Well, it's clear that understanding those basic principles of genetics is essential.
Okay.
But it's also about being curious, observant.
And willing to experiment, just like Aang with his habanero seedlings.
Yeah, he was really dedicated.
He was.
And even if you're not planning to create the next award-winning pepper variety, understanding these techniques can give you a deeper appreciation.
Absolutely.
For the incredible diversity and complexity of the pepper world.
It's amazing, isn't it?
It really is.
It makes you realize that each pepper, from the mildest bell pepper to the fieriest habanero,
it's true,
is the result of centuries of human ingenuity.
Wow.
Natural selection. And a whole lot of genetic magic.
It's like a superpower.
It kind of is.
Well, that wraps up our deep dive into the fascinating world of pepper breeding.
We covered a lot.
We've covered a lot of ground today.
We did.
From those tiny genes that influence germination speed to the cutting-edge techniques that are shaping the future of pepper cultivation.
So cool.
And we've learned a lot from Aang's experiment, too.
We have.
It's a reminder that even those small decisions we make about our planting techniques and soil composition can have a big impact on how our seedlings thrive.
They really can.
So for our listener out there,
we
hope you're feeling inspired to nurture those pepper plants.
Me too.
With a newfound appreciation for the science behind their growth.
It's really fascinating.
And if you're ever feeling curious about those genetic mysteries hidden within your garden, don't be afraid to experiment and see what you discover.
Exactly.
Who knows?
Who knows?
You might just uncover the next pepper breakthrough.
That would be awesome.
All right, pepper aficionados.
We're back.
We're back and ready to wrap up this epic habanero saga.
I know, so much to unpack.
We've explored the power of genetics, the influence of environment.
For sure.
And even delved into the world of plant breeding.
It's been a wild ride.
But let's not forget the star of our show.
Who's that?
Aang.
Oh, yeah.
And his quest to unlock the secrets of his unevenly growing seedlings.
Boy.
He's been diligently tending to his second batch of habaneros. The ones where he implemented those more controlled growing conditions.
Right. More consistency.
And I'm dying to know.
Tell me.
Did those efforts pay off?
Ooh.
Spill the beans?
They did in a big way.
Really?
Yeah.
So exciting.
Remember how his first batch had a wide range of heights? And some seedlings were clearly lagging behind.
Yeah, it was like some of them got stuck in the slow lane of the growth highway.
I love that analogy.
Well, in his second batch,
yeah,
with the consistent planting depth, spacing, and improved soil mix, the seedlings grew much more uniformly.
That's awesome.
So it was like they were all cruising along in the express lane together.
Exactly.
Perfect.
Aang observed that the height difference between the tallest and shortest seedling was significantly smaller in the second batch compared to the first.
That's amazing.
It is.
So even though those seedlings still had their own unique genetic blueprints,
Yeah, they did.
those subtle environmental tweaks really made a difference.
They did.
It's so cool how much of an impact that can make.
It's huge.
And it highlights a crucial point for all of us pepper enthusiasts.
What's that?
We can't change a seedling's genes,
Sure.
but we can create an environment that allows them to express their full potential.
It's like we're the stage managers.
I like that.
Setting the scene for those pepper seedlings to shine.
Yeah, making sure they have everything they need to succeed.
Exactly.
Now, even with the more controlled growing conditions, Aang still noticed some variation in growth rate among the seedlings.
Of course.
Which makes sense, right?
It does.
Because those CGR1 genes and other genetic factors are still at play.
Exactly.
It's a reminder that there's always an element of individuality in the plant world.
Absolutely.
Just like humans.
Right.
No two pepper plants are exactly alike.
And that's part of the beauty of it.
I agree.
It keeps things interesting.
For sure.
And ensures that each pepper harvest is unique.
So what's the big takeaway?
Yeah, what can we learn
from Aang's habanero experiment for our listener who might be battling their own seedling inconsistencies?
It's a great question.
Well, first, it's a reminder that those early stages of development are critical.
Totally agree.
Giving those seedlings a consistent and supportive environment from the get-go,
right from the start,
can make a world of difference.
Huge difference.
Second, even small tweaks to your planting technique and soil composition can have a significant impact on growth.
They really can.
And finally, it's important to embrace the variation.
I like that.
We might not be able to control every aspect of a seedling's growth.
That's true.
But we can certainly optimize the conditions to help them thrive.
Yeah, we can give them the best chance.
Aang's experiment is a great example.
It is.
Of how we can all become better gardeners.
Absolutely.
By observing, experimenting, and learning from our own experiences.
So true.
It's like he turned his seedling tray into a mini science lab.
Uh-huh. I love that.
And in the process, uncovered some valuable insights that we can all benefit from. So the next time you're starting your pepper seeds, remember Aang's story?
And his dedication.
And approach those tiny seedlings with a sense of curiosity.
Love it.
And a dash of scientific spirit.
Who knows?
And who knows?
You might just make some groundbreaking discoveries of your own.
That would be so cool.
Until next time, happy gardening.
And happy growing, everyone.